that means there's more water, hypotonic solution, the solution outside, yeah, I'm sorry, higher solid concentration in the cell. So the cell is hyper, pardon me, that's backwards. So if the outside is hypo, that means low solute, high water. And if this is hypo, the other environment will always be the opposite, it will be hyper. I can see more little dots there, fewer dots out here. Water goes from regions of higher to regions of lower, and the cell begins to swell.
Looks equal to me.
Just the opposite. Now we're saying, all right, the outside of the cell is hyper. It has lots of concentrations of solute. And if it's hyper, that's high solute, it's a region of low amount of water. The inside has fewer concentrations, so that is hypo, that has lots of water. The water goes from regions of higher to regions of lower through a selectively permeable membrane. So this is their little phospholipid bilayer they're trying to show you right in there. So because of water moving into the cell will swell, like blowing up a balloon. Can I keep blowing a balloon up indefinitely? No. What's going to happen if I blow it too much?
It's going
to pop, right? Your cells can pop. They can explode. Plant cells don't do it that easily because they have a cell wall that acts as reinforcement. But animal cells are a little fussy in terms of how much moisture they can absorb, which is why you have to have an isotonic solution in an emergency room. I don't want more water going into my red blood cells. Otherwise, like pop rocks, they're going to start exploding all over the place. And that won't be good for you. With an isotonic solution, then we have equal amounts of stuff across the cell membrane. There's no net movement. There's still movement of water, right? But not a net amount. So we get a tit for a tat. One goes in, one will go out. They just kind of balance each other out a little bit. We take advantage of that. That's one of the things that penicillin is able to focus on. It's how penicillin actually kills bacteria. It causes them to swell up because they get too much water flowing in. Because penicillin disrupts the cell wall. Not the cell membrane, but the cell wall. Remember, water can cross the cell's membrane, just not that quickly. So it's going to cause the cell to begin to swell and swell and swell. Normally, the cell wall is like a suit of armor. It keeps it from swelling up too big and popping. But now you get holes in it. You got like little geysers. You start getting cytoplasm starts squirting out, and that causes the cell to explode. I think, maybe we'll finish it, maybe we won't. So let's go back to osmosis. How do I know I'm dealing with osmosis? Because I see the words hypotonic, hypertonic, and iso. That makes me think about osmosis right off the bat. That means I know that I'm dealing with a solvent and a solute. I'm dealing with regions of high concentrations of water compared to regions of low concentrations. I just need to figure out which one's which. All right, so the beaker water is the environment of a hypotonic solution. So is that high water or high solute?
Solute. I mean,
it's high water or high solvent, right? Okay. That means then that the cell is the opposite of the environment outside the cell. So the cell, relatively speaking, is hypertonic. That means high dissolved stuff, low amounts of water. I now know where my high water is. I now know where my low water is. Water will move from regions of higher to regions of lower.
The next one will be opposite.
Right? Over here in the far right-hand side. Again, the beaker is my environment, and inside the cell is a second environment. I need to know where there's high water and where there's low water. So now the beaker has high amounts of solute, the low